welcome back to the main session. It's now time for our panel discussion. So may I please welcome our moderator, Dr. Naveed Anwar, to introduce all our panelists for today.
Okay, thank you, Jennifer, once again. And I think just keep this slide on for now, Jennifer. So let me welcome everyone. I think this has been a very, very fruitful discussion since the morning. The presentations have been just fantastic, and we have had a very good participation. Almost 300 people have joined, and we are very glad that we so much interest from our colleagues all over the region. People have been asking questions. The lively discussions have been happening. So we are just going to now conclude in this panel discussion and maybe hear from our speakers and other colleagues on the main theme of this event, which was on future-proofing our built environment, basically looking to the future of structural engineering in general and see what we should be doing or we can be doing to make things better for us as well as for the society and economy and everybody. And I think we should not forget structural engineering profession. We have to make ourselves also better in many ways. So I'm very glad to welcome our panelist, Professor Penning. I think most of you heard him in the morning. He's a professor of structural engineering at AIT, a very good friend of mine for over almost 25 years. We have been working together. So we share a lot of work on many projects, many research together. So I'm really glad that he could spare the time. Then we have Jose Sai, Engineer Jose Sai, the President and CEO of SY Square Associates in Philippines. His company is the largest structural engineering company in Philippines. And I think when I went to see him a long time ago, for the first time actually, and we were driving through Manila, and he was pointing to me that they have designed that building, they've designed that building, they've designed that building. And after a while, I said, just tell me which building you have not designed, because it seems that his company has designed almost all of the tall buildings, at least 90% of the tall buildings in Manila and Makati and other areas. And we have worked with him with SY Square for almost 12 years. And I'm very happy that we have jointly worked on the PVD of over 100 buildings. So we have gained some experience in this area, especially working with his team and him. And he has been guiding a lot of our work here, sending his team to work in AIT. Then we have Professor Murthy, as you heard him in the morning, the philosophy of structural life and structural engineering profession. So I'm very glad that he is kind enough to accept our invitation. Professor Murthy, as you know, is a renowned academician and also a policymaker with the government. In the morning, we had a full introduction with Professor Murthy. And then I also have the pleasure of having on my colleague for a long time in AIT Solutions. And now he's heading the AIT Solutions. And under his supervision, the team has worked on, like I said, more than 100 tall building and other projects with nonlinear modeling, analysis, and performance-based design and all. So we have really, experts from the industry, people who are half industry, half university, half government, and policymakers and researchers. So I think it's a good mix of panelists. So thank you, everyone. So I have one, I'm going to request each of the panelists to please give your brief view about what do you think of the future of structural engineering from your perspective, especially Professor Penning, starting with him on what the research and should be done in the universities to make sure that we develop the right knowledge for the next generation of structural engineers to come, and to provide them with the right tools for their application and their profession. So what are the hot areas of research that you think we should be done? Professor Penning.
Oh, I didn't know that you would start with me.
Okay, then I will not start with you.
You can start with Professor Murthy.
Okay, let me start with Professor Murthy. I think you're right. Professor Murthy, sorry, Professor Murthy, I think, let me, because you have a very broad view of the whole profession, and based on your presentation in the morning, I can see that you have, a broad view of not the profession, but as of the structural engineers and human beings also. And as sorry, part of the society. and the whole effect of the profession on many aspects. So may I request you to give your view on the building codes and where they should be going and how they should be helping us to remove some of the restrictions that we currently see. We all recognize as profession that non-linear analysis is needed, all these things are needed. Why aren't we making the progress in the building codes as we should be? So maybe tell us something about the policy and building codes in your view.
Yeah. Thank you, Anwar Saab. 2-3 things are there in the backdrop when we talk about ensuring safety through building codes. One bottom line is that today, most codes are looking at earthquake as a force and not as a displacement. And this is reflected by the fact that the entire seismic hazard assessment is for acceleration. Very few countries have just now got started to define displacement seismic hazard. And this is the time where we have to now shift the focus from acceleration to displacement. And once displacement hazard is known, then we will be able to walk towards assuring that the structures have the required deformability or not. Now, the deformability may come through damage in all the members, in select members, or through systems like base isolation or energy dissipation devices and so on. So my first thought for the new generation standards will be that we have to now robustly push for displacement seismic hazard also to be estimated along with the acceleration seismic hazard. And especially for taller buildings, this will become an issue. Especially for pipelines across the country, this will become an issue. The second point is that today, when we face the people of the country, we are not able to answer whether this building code will result in a structure that is safe or not. And safe, the word is whether it will collapse or not. And that is why I think the key point is what I raised this morning. We need a closed loop design method. You may do the traditional design by following all the codes of practice, but you still have to do one more exercise to make sure that the structure has the required deformability to say that it will stand after the so-called estimated design earthquake or the extreme event that is likely in that location. So assuring no collapse will become our prime responsibility in the new generation standards, as I can see. But on the same token, I will say that we have to bring more items on the table to be able to confidently say that the structure is good. And the other items are the 7 virtues I mentioned this morning. We are looking at a predetermined collapse mechanism also to come into picture, and also the energy dissipation, estimate of energy. So now we are working on energy-based design, where we are seeing how much is the earth shaking, how much energy is the earth shaking providing to a structure at any site from a certain distance from the fault. And can we make sure that the structure has so much energy capacity under cyclic shaking to resist that energy? So that will answer the 7th virtue, which is energy dissipation capacity of the structure. So we'll start with configuration, initial stiffness, lateral strength, and ductility are there right now. We need to move to level 5, level 6, level 7, which is deformability, collapse mechanism, and energy dissipation. So the standards that I'm expecting will go from the strength-based design to the next level, deformation-based design as the next immediate step, and then energy-based design as the second step thereafter. So on the whole, I think the accountability issue of those who are developing the standards, we need to answer this question as to what will be the performance of the structure. Will it stand there or fall down? This is where I think the focus will go forward further in time ahead, when people are talking about resilient designs and they want to reduce the downtime after an event. Countries which use very low seismic coefficient are not able to give that resilience. But as I see in other countries, seismic coefficient has gone up from 10% to 15 to 20, 25, 27, 30. They are seeing lesser and lesser damage, lesser collapse, meaning they are increasing the elastic range of the structure and using lesser amount of the inelasticity, because in most structures, especially concrete structures, you don't have large inelastic capacity. And that is where we are seeing that in standards to come, we will have to give the option to the user whether to how much damage to induce in the structure. So the codes will also go in that direction at some point of time.
Yeah. Thank you, sir. First of all, it seems that if we follow this trend and then we make the resilience or non-structural damage as the primary criteria, we may come back actually to the linear elastic design at some point. So thank you so much.
Possibly in some options for some structures that may become an option.
That may be, because then if you don't want no damage, or
Yes.
you want to protect everything, then you
Yes.
have to go back to linear range or something which is not practical, but we'll have to see.
Sure.
The cost implications will be very high. So
Yes.
Professor Penning, can I come back to you now?
I already forget your question. I think it's about the future. I think the keyword is about the research and the future.
Right, exactly.
What will be the future?
Correct.
So basically, I may not be able to answer this one because I cannot see the future. But the idea is we can guess what the future will be.
So what is your guess? I think we are all guessing. So what is your guess?
We are guessing on almost all the time. But what I know is if you are doing the research on a topic that all the engineers now know already, there's no use for that research. So we have to do the research in the future. So we look at the topics that will have a potential to be applied in the future. So that's what we are trying to do. Like what I present this morning, the June mass damper with multi-stage rubber bearing. I think that's also have the future because we think that it's quite compact, low cost, and it have many possible applications in the future. And if many engineers buy this idea, there's going to be applied to many tall buildings in the future. I talk about base isolation of tall buildings. They do this a lot in Japan, but not outside Japan.
Yeah.
But I can see that it can be applied to Philippines, it can be applied to India, can be applied to Indonesia, all these seismically active countries. So if we work on this research, if we provide the information for engineers in practice in the future, so all the researchers do this day is to guess what will be the future and work on these topics, prepare engineers in the future to be able to use this knowledge. If nobody use our knowledge, then our work becomes useless.
Yeah.
So what are
my
the
brief comment?
Yeah. So if I may ask you, what is your thesis for the next 5 years? Do you have any plan in your mind? What topics are you going to?
This will be secret.
Okay.
So you have to invite me next time.
Okay.
I really tell you some secret.
All right. So let me continue with that to Boise. Boise, President Penning was telling, thinking about what the researchers should be doing from the industry point of view, from the application, or from as a designer, facing the client and facing the projects. What do you think is the lack of research that you need and you cannot get? You wish that you had something, but you don't have. And what is your wish list that I would like to have this in the future that will make your job easier and make the profession, of your practice of your profession better, and answer the client's question? What are your most pressing needs that the researchers are not providing?
And I just want to pursue the dream of Dr. Penang regarding the base isolations. We actually tested some potential projects in the Philippines using base isolations, of course in collaborations with Japanese consultants as well as Japanese suppliers of base isolators. Of course, we also consulted AIT regarding this preliminary studies on the use of base isolator. The only problem that we always encounter regarding this base isolation is basically the cost. The cost of the base isolator at present price, I'm saying, they cannot actually justify now the possible savings on the structure. And you know that developers, almost every developers in every country, they always after the cost effectiveness, the construction cost on how much they're going to be saving, if you start introducing now certain new technology, certain new approaches. Like currently, we're actually doing a 1.3 million, square meter of, mixed use development. It has 6 towers on top, about 55-story building. And these are actually 6 buildings on a common podium. And I just couldn't even figure out if, our ETABS or Perform 3D can actually, run this one now in how many days or in how many weeks. You could imagine 6 55-story building sitting on a 7-hectare of podium. And then and then initially they even wanted that these 3 buildings are actually interconnected. So we told them that, and these are actually in shape of a T shape, L shape, I shape. No, we're saying it's so hard to really, but they're always after the efficiency of the layout in terms of how they're gonna save more of the core space, the fire exit in order to maximize now the sellable area, something like that. So these are actually challenges that we encounter on our current projects right now, because the projects they're getting bigger, they're getting complex, and then recently, perhaps in your country also, you experience that anything that is actually a metal-based material is actually going up in terms of prices. Rebar in the Philippines, they used to cost them only about 30 pesos or 28 pesos per kilo. Now they are about more than 40 pesos per kilo. And now the owners started asking us to, can we use a grade 75? Can we use grade 80? So these are things that they do not actually look at. Now they started looking at it simply because the cost of rebar is actually getting higher and higher. So now we are actually they're trying to interconnect now all this complex building into just one integrated building, and then ask us to really make it work, make it safe, make it perform. So these are just we always encounter because buildings are really getting bigger in the Philippines. Now we're doing a big development right now using energy dissipating devices, backlink restraint braces, external, but these are huge. These are about 6-7 story high. Though they actually require the special cranes just to lift this BRB in place. So again, these are in terms of preliminaries, in terms of logistics. This actually add cost now to the construction of the building. So I guess these are all the challenges. Of course, we all know that performance based is not yet widely used even in other countries, no. And we actually did, of course, so much buildings already using this approach, but we still believe that we're not so quick and so fast in actually completing those required tasks, no. So developers are still trying to really tell us to make it faster, because they want we know, but that we're actually buying additional time when we're doing a performance based compared to a linear analysis. So I guess these are things that we need to address, no, and even perhaps even not only the approach, but also the computing machines on how you actually do a 1.25 million square meter of development, integrated, common podium of 7 hectares, 60-story building, it's crazy, I tell you. Anyway, thank you. Thank you.
So what I hear from you, boys, is that you need faster software, you need
Faster
software
hardware,
with bigger capacity, you need better, methods that can handle, this, right, and also base isolation systems that are cheaper. So I can hear from you all the things that as the industry will demand: cheaper, better, faster, bigger,
and lower fee.
Lower fee also.
Lower fee.
Okay, so I think, so no, I completely agree with you. I think the demands but that is what drives innovation in any industry. When the demands from the end user are high, then the supply has to match with that. And I think when this becomes a common voice from many consultants, many people, then the people who develop software, people who do the research, they will have to come up with the solutions, because that's what is required. So I think you're absolutely, that's why your voice is very important in today's discussion, to really hear how the high-end consultants are, what kind of difficulty are they facing. So let me ask Ong a little bit, because he's sitting on a seat which is in between. Half is in university and half is outside doing the consulting work. So he hears both. He hears the arguments from Professor Penning, what cannot be done, and he also hears Mr. Boise, what is needed. So he has to balance the requirement from industry and the research from the university, and also the software limitation, because they actually have to do the work. So Ong, what is your opinion in terms of what kind of tools, what kind of things that you need or you think should be developed in the future? What are your challenges as a PBD consultant?
Let me talk about the next level of analysis and design procedure. Currently, AIT solutions working for many PBD projects. PBD, in my opinion, the technology is almost matured, and not all the consultants are doing, but many consultants are using that design approach in the design of tall buildings and existing buildings. So in PBD, we measure the performance in terms of safety objective. Okay, we design the building to remain elastic under a frequent earthquake, not to collapse under extreme earthquakes. And but we do not check explicitly for the economic loss in PBD. So next level of our design approach will be we have to consider the explicitly for the economic loss. It means that we have, after the strong earthquake events, after damage the building, how fast we can recover the functionality of the building and our infrastructure. So we will measure the functional recovery in terms of time in the next level, next generation design approaches. We call it a resilience-based design. So in that design approach, we will measure the performance in terms of time, functional recovery, which is not a reoccupancy. Reoccupancy is just safe re-entry to the building after the earthquake. Functional recovery is we have the performance is maintained or restored and safely and adequately support the basic intended functions. So
Right.
yes.
Go ahead, please go ahead.
So in that level of design, we need to consider the additional information in our design process, like casualties, repair costs, repair time, and another thing is environmental impact. If we need to retrofit the building, we need to use more materials. So we have to consider those information. Not because of that large information, we have to consider tremendous amount of information compared to our current PBD design. In PBD also itself, it is quite huge data. We have to analyze for 11 ground motions minimum to check the structural component responses, deformation, story drift, displacement, velocity, acceleration, and so on. So in our next level of design approach, more information is considered, and at the same time, more uncertainties will be coming in the design process. So if we need to deal with those uncertainties, we have to consider the probabilistic simulations in our design process. Currently, in FEMAR P58, they use the simulation. When we analyze the ground motions, 11 ground motions, it will not be enough to handle those uncertainties. So we may need 200 or 300 ground motion analysis in our design process. So in that approach, they start doing the large number of series of domain sets using mathematically transformation in their analysis. We are not running 200, 300 ground motions. We run 11 ground motions, but we will generate the domain series sets using the mathematical transformation.
Okay.
So,
Yeah. So I think what basically you're suggesting is that we need a more holistic design. Not only, I think this is a good opportunity, in my opinion, for structural engineers to get out of their comfort zone of just being a structural engineer and just calculating the reinforcement, and tell the client that we can do more for you. We can do a holistic evaluation of the building, including the facility continuation after the building. So we should start selling ourselves as people not doing the reinforcement design, but as people who basically satisfy or guarantee or provide the information about the whole life cycle of the building in terms of its performance to any kind of hazard. So I think if we place ourselves in that way, and then we will solve the problem of the low fee. We will probably get paid more if we can tell the client that we can do all that. And also, I think the BIM, if we have the BIM models with 6 or 7 levels, then that will automatically provide most of the information that you need, that Ong mentioned, for most of these analysis, so that it will be easier. And we should have access to that data from the client, from the architect, from the ME engineers. So I think it's, if we become as the center point, right now we are on the side of the building design process. I think we need a more central role. And if we can promote ourselves as engineers, that we will tell you whether the building is good, safe, or reliable or not just calculate the reinforcement, then I think our role can increase further. So just as a final round, what do you all think about this idea that the structural engineers should increase their role or increase their presence in overall design of the infrastructure of the buildings by providing greater services or providing greater information? Starting once again from Professor Murthy. So this will be the last round where we close, then we have a couple of questions.
What I understand is structural engineers are happy to provide services, but what Jose just mentioned, that the fee part is burning them off, actually.
People pay, Professor Murthy, people pay the fee when they see the value. Why the architects get such a high value? Because
having said that, I was coming to that. There are consultants in India, at least, who provide quality services and get the money as well. Yes, that is definitely them. That's the inspiring part. So what I would like to say is that structural engineers should definitely increase their skills and tools. Not just those which they got in their college days, but beyond that, they have to upgrade themselves, and especially nonlinear analysis. Then they will have a wider range of possibilities in front of them. That's the first one. But the success of structural engineer will also depend on the techno-legal regime of the country. If there is no enforcement system, how much ever good work you do, that will always be compared with the poor work done by somebody else, and you are more expensive than the other person. So I would say they are hand in glove stories. But my closing thought for today is that when I look at academia, when I look at research, when I look at practice, look at governments, the key worry is that, are we doing relevant work? Individually, we are growing, but the nation is not growing. So we are publishing papers in important journals internationally, but are we making a difference to the nation? So my request will be that all the simple problems have been solved in the world now. Only the difficult problems are left. If I can name one, retrofit the existing buildings in each of our countries. That itself is a big exercise which structural engineers can do very forcefully and make a big difference. So I would say, if we can solve the nation's burning questions, I think we will become center space for the nation to look at and say, these structural engineers have solved this problem. I think the dignity will be restored back if we are able to take up one such burning issue of the country and address it right away. So that's for the existing structures. And for the new structures, the promise is, let's not make any new building or any new structure collapse. So on that side, we improve the design methods, improve the design tools, maybe performance-based design. On this side, we need to do nonlinear response and then see how to retrofit existing structures. And both of these will win the hearts of every nation for the structural engineers. And I'm confident that in time ahead, structural engineers will come back to the fore in terms of the respect and dignity in the society.
Yeah. Very
Thank
well
you.
said, Professor. Thank you so much. That's exactly something that I wanted to, I was hoping to hear from you, and thank you for doing that. Yeah.
Ji.
Professor Pennan, what do you think? What the concluding comments from you? Unmute, please. Unmute. Yeah.
Okay. My microphone was mute, but I think the Professor Moti already answered everything.
Yeah.
Sorry
Including the
about that.
including the fee.
So I don't have anything to add. But actually, can I use this my time to discuss something that Mr. Boise actually point out, like a base isolation of tall buildings. That's something that we talk about the future, but from practicing viewpoint, it may not be practical yet.
Yeah.
Yeah. Well, I have a story to tell you. When I have one doctoral student came many years ago, and he proposed to work on some doctoral dissertation topic that I see that is not the future. So I asked him, convinced him that, okay, let's change the topic, work on base isolation of tall buildings. That can be the future of your country, can be the future of your business. He has his own company. So right now he has not finished his doctoral work yet, but he has a good business now. Right now he can convince many clients to buy his idea of isolate the buildings using base isolators. He's so busy with his business, so he cannot continue much with his doctoral work. I'm starting to worry about him now. So I think when we do a research work, we work on the future. If that topics have high potential, initially it may look expensive, but once we see the benefit, people will begin to apply that, and we see the impact. Of course, some topic we may see the future wrong, so we miscalculate that one. That can be the failure. Okay, but I think for engineers to upgrade our level, we have to work like a medical doctor. We have to keep learning the new knowledge. We have to read research paper. Like now we have a COVID-19. Many medical doctors are now studying very fast about this pandemic. Every day there's new research, new study. Now, not only medical doctor, everyone is studying this one. So we are become an expert in the pandemic. So I think engineers will have to be like this, very dynamic and self-learning. Continue to do this, and we will be in a better position in society. That's all my comment. Thank you.
Yes, and Om, what do you think?
Yes, I want to add a few more things. Not only focusing on the tall buildings and seismic hazard, we need to consider think for the vision or imagine the future problems for our infrastructures like roads, bridges, for the other hazards like floods, storms, wildfire. So these days we heard in the news frequent floods. It is more frequent than as earthquakes. So engineers, in future, we need to construct the defensive structures like sea walls, levee, barriers to protect our cities for the higher sea level rise due to the climate change and other natural disasters. We need to think, and we have to research to build our infrastructure for the future generations. If we we need to start thinking for next 50 years, 20 years, 50 years, and start doing the research. Because doing the new, creating the new technology, it will take time to get matured. So if we are too late, we will have problems in future disasters for our infrastructure.
Yeah, I think I completely agree on that. The multi-hazard is often missed in our. I mean, one time I remember I was hired by World Bank on some project, and they said you have to write something about the flood and slope stability or this kind. And I was wondering who does this. You know, it's not structural engineering, and I try to find out that it is not in any discipline. So it is just falling through the cracks. Certain things nobody's doing. So you're very right that we have to handle other hazards also, which we don't think important, but they actually cause more damage to the people than these the earthquakes, which and so yeah, I think this is a good point. Boise, what is your view?
Well, I like to touch, on Dr. Umuti, talk about the existing buildings. No, I was attending the special session on the building monitoring and assessment of existing building. So because in the Philippines, it's actually a very big market, because there's actually a mandate from the government saying that buildings that are actually 15 years and older, which are no longer under the liability of a structural engineer, must be reassessed, studied, and then recertified for an extended period of liability. Now, there are actually two school of thought. Most engineers are actually doing the assessment, in terms of linear analysis, meaning to say that they're trying to force now the old building to comply now to the provisions of the new code. So the result is actually a very, very expensive retrofitting work, because I still believe that you cannot actually design a building to comply to the future codes, because you only design a building to comply to the current code. So when you started looking at old buildings complying now to the new provisions of the code, then you end up really a very expensive retrofitting work. So I guess the approach basically here is it should be about nonlinear. It should be about assessment of an existing building using nonlinear analysis. That is actually the performance based. So that is actually one thought. That I guess as you were saying, Dr. Navid, that us engineers should actually go out of our comfort zone and start trying to explore a new approach, new things. And that is a reason why our business model in the office is that we collaborate with those who are actually expert in the industry. But like for example, AIT, we're working a lot with Japanese and even guys from Toronto, Canada. So because we believe that these collaborations will actually facilitate technology transfer. And if we are just actually confined within the comfort of our office, of our knowledge, of our what we actually know, we cannot actually grow. Now we have to admit that we have some limitations that we need to explore, we need to collaborate, we need to learn from other people. And I believe that collaborations really facilitate technology transfer, and that's where you start growing. As Dr. David was saying, that we've been working for the past more than 12 years. So we started with our GSIS project, our pushover analysis, nonlinear. So now we've been doing more than 150 buildings. If not with your collaborations, I think we'll still be stuck with the linear analysis. So I guess I agree with you guys that it has to be forward thinking. Yeah, we have to be forward thinking. You really have to learn something from the expert, and then from there you should actually move forward. Otherwise, you cannot actually grow. You'll be stuck with your current situation.
Yeah,
thank you.
Exactly. So
can I add something?
Yeah, please.
Yeah, I like to say that when from my eyes, when I look at Philippines, it's actually a big structural engineering lab. You have many structure waiting to be tested.
Yeah.
Tested by the strong earthquake shaking.
Yes.
Tested by the strong typhoon.
Yes.
So if you actually want to learn from that, we need to put instrument, structural health monitoring system into that. Then you will be the king of data. Everybody will come and want the data from you.
No, we're starting to explore that market with Mr. Ong.
Yeah, I think that the problem is you are not the one who pay for this.
Yeah, of course.
The client will pay for this.
Yeah. I think Ong, that Ong, we already put up some pro forma, proposal regarding health monitoring of existing buildings.
Yeah.
I think
if you have that amount of data and quality data about your structure, under seismic load, under wind load. We can learn from that data to the future. We will know better.
agree.
We don't have to have a consultant even from Japan or Canada or anything.
I agree. I
Actually,
agree.
we can learn from that, from our own structure.
I agree.
Yeah. So Bossy, here's a new business for you. Capture the entire building and instrument and become the king of data. And whoever has the data has the power.
Pass it on to Dr. Penang.
No. Sell it. Don't pass it to anybody. Keep the data. Okay. All right. So I think thank you so much. This has been not only very enlightening, but also very lively discussion. And I'm really glad that we were able to do this session. I see some people on chat thanking Professor Penang for making him laugh, because you said somebody saying that in such a serious situation, it's a very light in a session also, that so, and somebody said that they strongly agree with Professor Penang on instrumenting the building, getting the data and creating that into a big lab. So I think this is all related to what Professor Murthy is saying and what Ong is saying. We have to go beyond what we do now and find new services that we can offer, new things that we can do, new contributions that we can make, and then benefit us and the society and the country and our region and everybody. So I think we have to start thinking, not just calculating reinforcement for bending moment. I think that is, we have to get away from that, or applying some load factors or capacity factors. They are all needed. But as we progress, we should be thinking beyond that. And we need all levels of input. So that's why in my class, I always say to my new class when they start, I say, do you want to be an engineer, a designer, or an artist? So I think we have to be all, or a philosopher. So gradually we all have to be everything as we progress through our careers. So I think with that, I would like to thank everyone, all the participants who joined in the morning and joined in the afternoon. And we had some very lively discussions in the forum, and then such a wonderful discussion in the panel. So I'm sure that it was also useful for all the participants. Please feel to write to us, all the participants. Anything that you have in any question, we will be happy to answer, pass it on to our panelists or other colleagues. So please keep in touch with us. And once again, thank you, everyone. Especially all the panelists. Professor Murthy, thank you so much for your time. I know how important it is for us to have your time. You're so busy. Professor Penang, Boise, Ong, and everyone. So thank you all.
Thank you. Thank you.
Thank you, guys.
Thank you.
Jennifer, you want to say something, or is that the end?
That's the answer. Thank you, sir,
Okay.
for
All
concluding remarks.
All right, thank you.
Please follow us on Facebook, AIT Solutions. We will post there the link to download the materials that you've been requesting us. So we've been asked if they can have the presentation of our speakers today. We will ask for permission from all the speakers, and we will put the link in our Facebook. And also, please visit our website, www.solutions.ait.ac.th. And let's keep in touch on Facebook. Stay safe, everyone. Thank you for joining us today.